Welcome to our course on software testing, where we'll dive into the foundations of mobile application testing. In this first week, we're focusing on what drives mobile business, how app architectures shape testing, and the unique challenges that come with it. Let's get started and build a solid base for everything to come. Today, we're diving into the world of mobile business and technology. We'll start by exploring the difference between testing mobile devices and testing mobile applications, two areas that often get mixed up. Then, we'll look at the mobile device ecosystem and the various types out there. Next, we'll break down native, web, and hybrid app architectures. Finally, we'll tackle the key challenges in mobile quality assurance and the strategies to manage risk. That's the roadmap for today's session. Mobile testing isn't just a technical step. It's a business imperative. With millions of apps out there, every user counts. A single crash or freeze can make over half your users uninstall your app. That's a direct hit to revenue and reputation. On top of that, rapid release cycles, sometimes weekly or even bi-weekly, demand continuous, automated testing. It's how we keep pace with both technology and business needs, ensuring quality without slowing down innovation. Let's talk about why mobile testing really matters to the business. First, security and compliance are huge. Payment gateways, handling personal data, and meeting regulations like GDPR or HIPAA all need to work flawlessly on mobile. Then, there's the business side. For freemium apps or those with in-app purchases, any broken payment logic means lost revenue fast. And if your app relies on ads, buggy ad displays can kill the user experience. Mobile testing keeps both the technology and business goals aligned and thriving. Let's start by clearing up a key distinction: mobile testing versus mobile application testing. Mobile testing is broader. It looks at the device itself, its hardware, network, and overall performance. Mobile application testing, on the other hand, zooms in on the apps running on those devices. It's about making sure each app works smoothly, reliably, and meets user expectations. Understanding this difference helps us focus our efforts where they matter most. When we talk about mobile devices today, we're really facing a huge variety, a true diversity of shapes, sizes, and capabilities. Smartphones come in all sorts of screen ratios, from the classic 16:9 to taller, narrower formats. Tablets often focus on multitasking, with landscape views taking priority. Then there are wearables, smartwatches with tiny screens, limited memory, and interfaces built around quick notifications. Foldables and dual-screen devices add another layer of complexity, with screens that resize dynamically while you're using apps. On top of that, hardware features like accelerometers, gyroscopes, biometric scanners, and NFC all change how apps interact with the device. Testing across this landscape is a real challenge. It's not just mobile testing. It's mobile application testing in its fullest sense. When we talk about mobile applications, there are three main types to keep in mind. Native apps are built specifically for one platform, like iOS or Android, giving the best performance and user experience. Mobile web apps run through a browser, so they work anywhere but can feel less smooth. Then there's hybrid apps, a blend of both, combining web technologies inside a native container. Each has its strengths, and choosing the right one depends on what you want to achieve. When we talk about building apps, there are three main ways to approach it. First, native applications. These are built specifically for one platform, like iOS or Android, giving the best performance and user experience. Then, mobile web applications, or PWAs. These run in a browser but feel like apps, offering flexibility across devices. And finally, hybrid applications, a mix of both, combining native features with web technologies. These three architectures shape how we create and deliver mobile experiences today. When we talk about high performance and platform integration, we mean apps built specifically for one operating system. These native applications use platform-specific tools and languages to get the most out of the device. For iOS, that means Swift or Objective-C with Xcode. On Android, it's Kotlin or Java using Android Studio. This approach lets us dive deep into each platform's capabilities, delivering speed and seamless integration that cross-platform solutions often can't match. Let's talk about what makes native applications stand out. First, they have direct access to device hardware, things like the camera, Bluetooth, and GPS. This means they can use features your device offers without any middleman. They're also distributed through app stores, like the App Store or Google Play, making installation straightforward. And importantly, native apps can work offline, storing data locally with databases like SQLite or Core Data. These characteristics give native apps their speed and reliability. When we talk about testing focus for quality assurance, there are a few critical areas we need to zero in on. First, hardware resource consumption, making sure the app doesn't hog the CPU, drain the battery, or leak memory. Then, compliance with App Store submission guidelines, a must to get your app approved. We also look closely at local data storage security and how well the app clears its cache. This slide takes a deep dive into native applications, where these concerns really come into play.
Let's talk about browser-bound accessibility. That means building web apps that work smoothly right in mobile browsers. We use standard web technologies like HTML5, CSS3, and JavaScript to make sure these apps are accessible to everyone. Then, there are progressive web apps, or PWAs. These take things further by using service workers to enable offline access and push notifications. It's a powerful way to bring app-like experiences directly through the mobile web. Today, we're diving deeper into how these technologies shape mobile web accessibility.
Let's look at some key characteristics of mobile web apps and progressive web apps, or PWAs. First, they don't need to be installed through an app store. You just access them via a URL. They run on a single code base, which means the same code works across all platforms. But there are some limits, like restricted access to hardware features such as Bluetooth or NFC. This balance shapes how these apps function and what they can do. When we talk about testing for quality assurance, there are a few key areas we focus on. First, cross-browser compatibility, making sure the experience works smoothly whether you're on Safari iOS, Chrome Android, or Firefox. Then, responsive design testing, checking how the layout adapts across different screen sizes and viewports. We also test network disconnection resilience, ensuring offline mode works when the connection drops. Today, we're taking a deep dive into mobile web and progressive web apps, where these challenges really come to life. Let's talk about web technology inside a native shell. This means building apps with web tools, like HTML, CSS, and JavaScript, then wrapping them in a native container that lets them run like regular apps. Frameworks like React Native, Flutter, Ionic, and Cordova make this possible. They bridge the gap between web and native, giving us flexibility and access to device features. This approach is what we call hybrid applications, and it's a powerful way to combine the best of both worlds. Let's talk about what makes hybrid applications stand out. They use a single code base that works across platforms, but still deliver a native look and feel. How? By tapping into native hardware features through what we call bridges or plugins. This approach lets us combine the best of both worlds, efficiency in development, and a seamless user experience. It's a smart balance that's worth understanding deeply. When we talk about testing focus for quality assurance, there are a few key areas we zero in on. First, bridge performance. That's where JavaScript meets native UI rendering, and bottlenecks can really slow things down. Then, plugin failure handling. For example, what happens if the camera plugin crashes on a certain Android version? Finally, UI inconsistencies, those pesky layout bugs that show up differently across platforms. This slide takes a deep dive into the unique challenges of hybrid applications. Let's break down the main differences between native apps, mobile web or PWAs, and hybrid apps. Native apps deliver lightning-fast performance and full hardware access, but they come with higher development costs and require installation through app stores. Mobile web apps run in browsers, so no installation is needed, and costs stay low, but performance and hardware access can be limited. Hybrid apps strike a balance, offering high performance through bridges and good hardware access via plugins, with medium costs and app store distribution. Each approach demands a different quality focus to get it right. When it comes to mobile QA, there are 5 big obstacles that keep us on our toes. First up is device and OS fragmentation. With thousands of Android devices out there and multiple iOS versions, testing gets complex fast. Then, unpredictable networks add another layer of challenge. Apps need to handle seamless switches between 5G, 3G, Wi-Fi, even sudden loss of signal or airplane mode. These factors make mobile application testing a real puzzle to solve. When we test mobile applications, we face some unique challenges that can really trip us up. First, interruption handling, things like phone calls, text messages, or push notifications popping up right in the middle of a transaction. Then, resource constraints, limited battery life, devices slowing down due to heat, or apps getting killed because of low memory. Finally, localization and geolocation, making sure the app works across different languages, time zones, and location-based restrictions. These factors make mobile testing a complex puzzle to solve.
When dealing with fragmentation and limited time, we need a smart approach. First, focus on a target device matrix. Use analytics tools like Google Analytics or Mixpanel to identify the top 10 devices your users rely on, those that make up 80% of your audience. By prioritizing these, we can test where it matters most. This risk-based mobile testing strategy helps us use our time efficiently, ensuring the biggest impact without spreading ourselves too thin.
When we start testing, emulators and simulators are our best friends for early functional checks. They let us catch issues quickly, without needing the actual hardware. But as we move forward, real devices and cloud labs become essential. That's where we test the full system, usability, performance, everything that really matters to the end user. This balanced approach ensures we're thorough, efficient, and ready for anything. It's a strategy that keeps testing smart and practical. Our third strategy focuses on automation, specifically, automating those repetitive sanity and regression smoke tests. By using tools like Appium, we can cut down the time spent on manual testing. That means testers get to focus on what really matters: exploratory testing, where human insight makes all the difference. Automation takes care of the routine, freeing us up to catch the unexpected. Let's break down the key business drivers behind app development. Apps bring in direct revenue, but negative reviews can damage brand reputation in an instant. When it comes to testing, device testing checks hardware and operating systems, while app testing focuses on how the app itself functions within that environment. Different architectures matter too. Native apps deliver top performance, web apps offer universal access, and hybrid apps strike a balance with cross-platform efficiency. To manage risks, analytics-driven target device selection helps us tackle fragmentation challenges head-on.
We've wrapped up today by looking at some key questions, like what kind of test would catch a crash caused by an incoming call during checkout, and why an enterprise might pick a hybrid app over a native one, even with some performance compromises. Next time, we'll dive into testing device hardware compatibility, software interruptions, and how apps handle switching between networks. Now, let's open the floor for your questions and thoughts.
This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.